Alright, like I said, we are finding the derivatives of functions that involve trig functions, mainly sine and cosine. We'll get to the other trig functions later on down the road, but today we want to look at finding the derivatives of sine and cosine. And then we're going to look at 3 different types of application problems with the derivative. That's what we're going to do. So that's what we're looking at today. 2 new derivatives you need to know. Okay, and let's talk about what this notation is telling us. What this notation is telling us is that we want the derivative of what's inside. So this over here tells me we want the derivative, and then that's what we want the derivative of. That's what that notation means. And the derivative of sine is equal to cosine, and the derivative of cosine is equal to negative sine.
Negative.
So the derivative of sine is equal to cosine. The derivative of cosine is equal to negative sine.
What is the significance of the brackets?
I just told you.
It's the inside.
Oh,
What's inside the brackets is what you're taking the derivative of. So y equals pi over 2 sine of theta minus cosine of theta. And I want to find the derivative of this. Now, what is that pi over 2? What is it? What can I label that pi? Don't be looking over there. What can I label that pi over 2? It's a constant
Pi over 2.
coefficient.
Yeah.
That's
it's
what I'm
just
listening. What I'm listening for. So what happens to constant coefficients when I'm taking derivatives?
0.
No,
take them out.
They stay the same.
They stay. So that pi over 2 is going to stay. What's the derivative of sine?
Cosine.
Cosine. And then minus, what's the derivative of cosine?
Negative sign.
Negative sine. So I clean it up a little bit. So that is pi over 2 cosine of theta plus sine of theta. All right, before I take the derivative of 6 times the square root of x, what do I want to do with that square root of x?
Get rid
X.
put an exclamation.
Right, make it 6x to the 1/2. So when I take the derivative, 1/2 times 6 is 3. I subtract 1 and I get
Negative 1/2.
negative 1/2. Over here, the 5 is a constant coefficient, so it stays. The derivative of cosine is
Negative.
negative sine. And I rewrite it to clean it up a little bit. So I get 3 over x to the 1/2 minus 5 sine of x. Alright, my directions say find an equation of the tangent line to the graph of f at the given point. So we want to write the equation of a tangent line. What 2 things do I need? And this is something I say over and over again. To be able to write the equation of a tangent line. Slope and a point. They gave me the point. Where do I get slope from? From the derivative. So I need the derivative. I need to rewrite this before I can find the derivative, though. That would be 2 times x to the negative 3/4. So when I find the derivative, negative 3/4 times 2, what does that give me?
Negative 2. No,
Negative
3/2.
Negative 3/2. And negative 3/4 minus 1.
Negative.
Negative
Negative
1/4.
Negative 7/4.
Negative 7/4. You're subtracting 1. Alright, so I rewrite it. I get negative 3 over 2, 4th root of x to the 7th. There's my derivative. I want the slope though, so what do I need to do to my derivative to get the slope? I need to plug in my x value. So I need my derivative evaluated at 1. So if I plug 1 in, that gives me negative 3/2.
Yes.
So now I'm ready to write my slope. What form am I going to use? Or my line? I'm going to use point slope. So So that would be y minus 2 equals my slope, negative 3 halves, x minus 1. There it is. Okay, let's go ahead and do part B just to verify what we're doing. It says use a graphing utility to graph the function and its tangent line at the point. So let's graph both of those things and show that we did it correctly. We have the function, and we wanted the tangent line to be at the x value of 1, and what was the y value?
2.
The point 1, 2 is my tangent line at the point 1, 2. Yes, it is, so we did it correctly. It says determine the point or points, if any, at which the graph of the function has horizontal tangent lines. What do I know about horizontal tangent lines?
Y equals
Slope is 0.
They would have a slope of 0. Good job. So how am I going to use that fact to help me find the x values where that happens?
You find the derivative and then set it equal to 0.
Awesome. As he said, I'm going to find the derivative. I set my derivative equal to 0 and solve. That'll tell me at what x values my derivative equals 0. So let's start with the derivative. So that is 4x cubed minus 4x squared. So there's my derivative. There's part 1. Jared, what was part 2?
I set it equal to 0.
Set it equal to 0. So 4x cubed minus 4x squared. What can I do to help me with that? Melody?
Take out 4.
4x squared.
Why don't you say something?
It's just
Hold on.
supposed to be 4.
Thank you.
Okay, good eye.
So that leaves me with x squared minus 1. Nope. That is x minus 1, x plus 1, correct?
Yeah.
We should be able to see what my 3x values are. What are my 3x values?
0, 1, and
Negative 1.
0, 1, and negative 1. Now what should be happening at those 3 values?
The line, tangent line is horizontal.
The tangent line should be horizontal, so let's look at the graph of that. So there's my graph of that function, and we said x equal, what x values? 0, 1, and negative 1. So look at those x values of 0, 1, and negative 1. If I were to draw a tangent line, would they be flat? Yes, they would be.
Yeah.
Because my tangent line, or my points would be here. It would be here, there, and there. And if I were drawing a tangent line, these two would have the same one, and that one would be there as well. Now, what else is going on at these x values? What do I have at those x values?
Minimum and maximum.
I have minimums and maximums. Good, Garrett.
No, you cannot tell me.
Garrett was on point.
So I have minimums and maximums where we had a tangent line slope of 0. That's going to come into play on down the road. Because whenever I take my derivative and I set it equal to 0 and I get x values, those x values are what's called critical numbers. Okay? Now, what types of mins and maxes do I have here? Because there's 2 types of mins and maxes. Do you guys know what the 2 types are?
Did you say
Relative, and the other one is absolute. Okay? Which type are these?
relative?
They're relative, but actually the minimums are also
Absolute.
absolute minimums. Why are they absolute, Garrett?
Because they're a pair.
No?
Because there's no point lower than it.
Yes, if they're the lowest low point, then they have to be absolute. The highest high point gives me absolute maximum. Very good, Chris.
What's
it's
a-
So,
still-
These points right here are relative. They are relative minimums and they are absolute minimums.
What is
Now,
relative?
this one right here is only
Absolute.
relative
Relative.
because there are points that are higher than that relative maximum.
What does relative mean? Just like
like a relative max will have points above it.
No.
Just talk. Just say it.
We're going to define them more on down the road. The relative extrema, when we say extrema, we're talking about relative maxes and mins. We're talking about when extrema means both of them together. Relative extrema can only happen where my derivative equals 0. Okay? And like I said, whenever we find our derivative and we set it equal to 0 and we get x values, those x values are called critical numbers. Okay, and extrema can only happen at critical numbers. And at critical numbers, it's either going to be an extrema or it's going to be something else called a point of inflection. And on the next problem we do, or another problem we do, yeah, it's the next problem. Next problem is going to be a point of inflection, and I'll show you what a point of inflection is. Okay? The relative extrema can only happen at critical numbers. And I'm interested in where this thing has horizontal tangent lines between 0 and 2 pi. So again, Amelia, what do I need to do to get started? Find the derivative. What's the derivative of x? 1. What's the derivative of sine? Of sine. So April, after I find the derivative, what do I want to do?
Set it equal to 0.
Set it equal to 0. Okay, Cole, what do you want to do next?
Solve for. Solve for.
What do you do?
I want to get cosine by itself. And once I get cosine by itself, I'm interested in what x value between 0 and 2 pi makes cosine equal to -1. Pi does. So, at the x value of pi, I have a horizontal tangent line between 0 and 2 pi. So, let's see what that graph looks like. Now, let me see if I can show you exactly trace. So we should, let's see where pi is. Pi would be 3 point, and I wonder if I can plug that in. About right there, well, 3.3. Somewhere between here and there is pi. And can you see that it will have a horizontal tangent line? But this time, last time, whenever I had a horizontal tangent line, what was going on with my graph? What did I have? I had relative extrema. This time, do I have relative extrema there? No, I don't. This is what's called a point of inflection. Okay, where I have a horizontal tangent line, but I don't have relative extrema. That's a point of inflection. And that's also down the road, and I'll be able to explain a point of inflection a little bit more. Okay? But this is a point of inflection right here. F of x equals k over x, and y equals -3/4 x plus 3. Alright, now you guys are going to think with me on this one. Help me out on this. It says, find k such that the line is tangent to the graph of the function. So that line over there on the right is what type of line? It's the tangent line to the function that's on the left. Okay, and there's two things we need to realize to be able to help us figure out what k is. What are those two things? I need to know two things about the relationship between my line and my function.
Wait.
Speak.
I'm just guessing.
It's good to talk and just think. Think out loud so other people can hear what you're thinking. What were you thinking, Jack? Please tell me what you're thinking. What about the slope?
You put too much pressure on me now.
I'm not trying to put pressure on. I just want you guys to think out loud so everybody knows how everybody else is thinking. That'll help you. How are these two things related? There's two things we need to be able to identify. That's going to help us figure out what k is. What?
The points they share?
They share a point. There's number one. Is that I've got a tangent line and I've got a function and they share a point. So that's the first thing I need to know.
You said there's gotta be something else now.
Right. Their slopes are the same where?
At that point.
At that point.
Good.
So those are the two things we need to know. Because where do I get slope from if I'm talking about my original function?
The derivative.
The derivative. So what do I want to do?
Find the derivative.
Find the derivative.
Of both or just the line?
No. of the function. I want to find the derivative of the function, so let's go ahead and do that. Let's rewrite it first. So that would be kx to the negative 1. I take the derivative, that would be negative kx to the negative 2. So we're looking at negative k over x squared. Now that's the slope. Do I know what my slope needs to be?
Yeah, 3, 4.
It needs to be negative 3/4, doesn't it?
Yeah.
So what do I do to negative k over x squared?
Set it equal to negative 3.
I set them equal to each other. Because my
Negative
slope-
3.
My derivative, my slope, has to be equal to negative 3/4. Right there. Those two things have to be equal. But I'm looking for k, and I've still got that x to deal with. So there, I have to go back to what else did you guys say? They share a point. So if they share a point, what does that mean about my original function and my line? They meet somewhere, and if they meet somewhere, what does that mean about the two functions?
They can have the same slope.
Here, let's go back
They can
to
be the same line.
let's go back to algebra 1. If I've got a line here and I've got another line here,
They're intersecting.
Their slopes have to be.
they're intersecting.
Yes.
So if these two things are intersecting, how do I find that point of intersection?
You set the. No, you don't.
But then the slopes can't be the same if they're intersecting.
If they,
If I have two lines and I want to know where those two lines intersect, what do I do?
You set the equation equal to each other.
I set the equations equal to each other.
yes, Gary.
So if I've got a function and a tangent line and I know they touch each other and I want to figure out where they touch each other, what do I do?
Set them equal to each
I set them equal to each other.
I feel like
Yeah, well, third hour was all over it. So I need k over x equals negative 3/4 x plus 3. If two functions share a point, they have to be equal to each other at some point. All right. So here's what we want to do. Oh, back over here when we were dealing with our derivative, let's get k by itself. So if I get k by itself, the negatives go away, and I end up with 3x squared over 4 equals k. Once I figure out what k is, then I can come over here on the right and do what? Plug it in. So I have 3x squared over 4 over x equals negative 3/4 x plus 3. What happens to that x squared and the x over there on the left?
Multiply with
These two things reduce. So I have 3x over 4 equals negative 3/4 x plus 3.
Now you want to get that negative 3/4x by itself.
I need to get the x's on the same side.
That's what I'm
So
saying.
you need to add 3.
So I add 3/4. So what's 3/4 plus 3/4?
6 over. No.
6 over 4, which reduces to 3/2.
And then you want to multiply each side by 2
Two.
thirds.
Multiply by 2/3, and I get x is 2. Once I know what x is,
That is
I plug x in over here. So I plug 2 in, which is 4. Those reduce, and that means k is 3.
Now, when I was on the derivative, the k is multiplied by the x. If you
Is that
take the derivative of it, the
That's
k
a lot.
go away.
You hear me?
What did you say? I'm not following you.
You have k by itself,
Yes.
You hear me?
not with the x. Whenever you find the derivative, does the k go away or does the k stay there?
If the k is by itself without an x, the k goes away
Okay.
because the k is a constant. So that means, so if I put 3 in here, and I make this 3 over x, and I graph this thing, and I graph that, what should happen?
They should intersect.
They should intersect, and that line should be what? Tangent to that line. So let's verify that we did that correctly. At what x value should they be tangent? 2. At the x value of 2, which is right here, I should be tangent. So let's see if we did it right. Drum roll, please. Yes, we are correct. Okay. So f of x equals x squared minus kx. Somebody tell me what the tangent line is.
Y equals 5x minus 4.
Alright, so I need to figure out what k is. That's the tangent line to this function. So we need to do 2 things. What do we need to do?
Derivative of function.
Find
Find
the
the derivative.
and
So that is 2x minus k. And what do I do with the derivative? Set it equal to the slope. And what's my slope? 5. And let's go ahead and get k by itself. So I'm going to add the k over, and I'm going to subtract the 5. So that's the first part I needed to do. What was the second part I needed to do?
point.
And how do I get that?
Setting them equal.
Set the functions equal. So I do x squared minus kx equals 5x minus 4.
And we found k.
I found k, so I plugged k in. So x squared minus 2x minus 5 times x equals 5x minus 4. So I want to distribute. If I distribute, that is 2x squared plus 5x equals 5x minus 4.
And then 5x is minus.
So these two give me negative x squared. These two cancel.
No, they don't.
Yeah, they
Yeah, I
do.
do.
They do?
You subtract the 5x
Oh,
from
yeah.
the right.
Never mind.
The negatives cancel, and I end up with x equals
Plus.
plus or minus
Yeah.
2.
God.
All right. So once I know that, then I come back over here. How many k's am I going to have?
2.
I'm going to have 2. So I plug in 2, which gives me
-1.
negative 1. I also need to plug in
-2.
negative 2, which gives me,
Negative.
yes, as you said, negative 9. So I've got 2 actual functions that will work with that. So I have x squared plus x will work, and x squared plus 9x will work. So let's check both of those real quick. And this one should be tangent at 2. So that one's tangent at 2. Now my other function was x squared plus 9x. So let's go back in here and let's change that to 9x. And this one should be tangent at
-9.
negative 2.
-2.
And if I get enough screen, you will see down here at negative 2, it is tangent. So that's what you were doing there.